Hi, everybody, and welcome to my breakout session. It's called the Cisco SD-WAN, the usual suspects, and we're going to look at some common culprits in WAN Edge onboarding. My name is Gina Cornett. I'm a technical marketing engineer for the SD-WAN product. I've been working there for about 4 years, but with Cisco 26 years. And I typically work with a lot of design with customers, and I do a lot of design guidance and writing of design guidance. So. We have a packed agenda, so I'm hoping we can leave our questions to the end. We do have a WebEx chat session associated with this breakout session. So if we don't have time to answer some of those questions, we can always go to you can find this, log in through the Cisco Live mobile app, and my colleagues and I will be happy to answer any questions that you have. Okay, so let's talk about what our agenda looks like for today. When we talk about WAN Edge onboarding, what we're talking about is we have a WAN Edge router we're pulling out of the box, and we are getting it up, online, engaged, and fully participating in the Cisco SD-WAN fabric, right? There are three distinct areas I wanted to cover, three distinct stages in onboarding, and I broke it down into the vBond control connections, the vManage vSmart control connections, and then lastly the WAN Edge data plane connections. So I like to think about those into three different stages. Within those stages, there are definitely things that can go wrong. There's a lot of moving parts. The areas that I want to focus on in each one of these stages are Sorry about that. But in the areas of reachability, authentication, and authorization. So that's where our usual suspects are typically lurking. Okay? So let's first talk about what we want to cover here and what I hope for you to get out of this session. For one, we're going to focus on the physical WAN Edge routers, the ones that are running iOS XE SD-WAN. And I'm going to focus on a manual onboarding process. This is where we get on the console, we paste, or configure something very minimal for our WAN Edges to come on board. I figure if at least we talk about that, you'll understand the requirements that are needed for those devices to onboard successfully. And once we have that, you can certainly apply those same concepts to other types of onboarding. Okay, so what I want to do is give you guys a very strategic and focused approach to how to identify these usual suspects when you're onboarding. So we can recognize the common pitfalls. We want to be able to triage our issues very we can have a reduced time for triaging our issues, and I hope to give you some tools that you can use to take away to actually troubleshoot some of these common issues. Okay, some things we are not going to talk about today are, we're not going to really talk about a lot of foundational topics, only to those that apply directly to onboarding. We won't have enough time to cover the rest. So that's what we're going to be focusing on. Now, before we can really talk about where our problems sit, we really need to understand how onboarding works. Because once we understand how that works, how the process works, we can then be able to identify when there's problems that arise. So we have a network here of one vBond, two vSmarts, and a vManage. And I have a WAN Edge router coming into my network. So the WAN Edge router will make initial control connection to the vBond. Now the vBond will authenticate and authorize this device. And in turn, it will also, once that happens, it will pass a list of the vSmarts and vManage that it needs to connect to. So now it knows how to connect to these other devices. So the WAN Edge will make a connection, try to make a connection to vManage. It'll authenticate and be authorized. And if the vManage has a full configuration for it, it will download that. Now the WAN Edge will also make connections to these vSmarts, and by default, I'll connect to two vSmarts over a single transport. Now that I've got my connections in place, my vManage, my vSmarts, my vBond is a transient connection, can now go away. Now, my vSmarts, I'll form, now that I've got my control connection to them, I can form OMP sessions, or overlay management protocol sessions to them. Now, let's go back and let's talk about some keywords. One is TLOC, we talk about quite a bit. That's a transport location. That's really the entry point into the WAN transport. It becomes like the next hop for my LAN side routes. it also becomes the point where I can initiate my data plane tunnels as well as terminate those data plane tunnels from other devices. So I will take my TLOC information and my service-side routes and my encryption keys associated with those TLOCs and advertise them to vSmart. A vSmart will turn around and send that information to other WAN edge routers. And I will also, in return, get that information back from vSmart on how do I connect to these other WAN edge routers. So now I have enough information that I need to basically form my data plane connections, okay? So now we know that, I mean, we often don't just have one transport, right? We have multiple transports here. So when we have the vManage actually sends us our full configuration, we can configure these other transports that we might have, and once I have the correct configurations, I can go ahead and make those control connections as well over those transports. So, and once I have that, my vBond connection can go away. If you notice, we did not have to make a vManage control connection. vManage, we only need to connect to over one of those transports. And then now that we have connection to our vSmarts, we can then, exchange our TLOC information, and then now we have another data plane connection we can build. Okay, so in summary, what does successful onboarding mean? Complete onboarding, right? Well, successful complete onboarding means, I've got some connections to a vBond over each transport that's transient. So once I can make my permanent connections to my controllers, those can go away. I'll make one connection to a vManage over one of my transports, and then I'll make 2 vSmarts by default over each one of my transports. And then, of course, I will then need to worry about my data plane connections after that. Now, the interesting thing is if you are working on a network and you see you have vBonds that are still, that are basically being persistent, then it kind of gives you a clue that there's something going on there and something not right, and so you should investigate a little bit further. Okay, so our first step is we're gonna go and talk about our vBond control connections. Okay, this is our first stage. We have a WAN edge router, we're trying to reach our vBond. We're gonna go through authentication, authorization, and then the three areas that we're really concerned about here are, 1, reachability, 2, authentication, and 3, authorization. So where do our usual suspects hide? When we talk about reachability, we're asking ourselves, different questions. For one, is our control traffic being initiated? That's important. Is control traffic actually being initiated? And if it is it reaching the controller? Okay, and if it is reaching the controller, is it making it back, to our WAN edge router? Those are the questions we ask ourselves. When it comes down to authentication and authorization, obviously the questions are, is that succeeding? So these are the things that, we have to ask. So a really important question, a really important command that we use when we're doing some troubleshooting is the show SD-WAN control connections command. So this will tell us, if there's connections being negotiated or if there's connections that are established. Now, it'd be great to be able to go to our vManage, and look there, but unfortunately at this stage, we don't have vManage connections. So this actually will give us some really good information. So following this is another good command. Because if we see, that we don't have these control connections there, we can actually go a little bit deeper, and we can look at the show SD-WAN control connection history, right? So if there's something connections aren't forming, we can actually come down to that history command and see if there's any errors that have been generated. So we can actually do this with any one of our SD-WAN devices. When you look at the vManage and vSmart, you can run a show control connections as well as show control connections history. For vBond, the keyword is orchestrator. So you run a show orchestrator connections or show orchestrator connections history. Why that's important is that if you run a show control connections command on the vBond, it will work, it just nothing will show up. So you'll end up troubleshooting, it'll basically send you off into a black hole for a little bit as far as your troubleshooting goes. Okay. So one of the questions we ask ourselves when it comes to reachability, is control traffic being initiated? So if I run this show SD-WAN control connections command a few times and I don't see anything, okay, tells me I'm not even initiating traffic. If I run the show SD-WAN control connections command and I do see something there, well, I see that I do have some connections at least trying, because because I have this guy in state connect, so I do know that it is trying. So basically, we have to treat these two things separately, and we troubleshoot them separately. So for things that are not, in the first section where control traffic is not being initiated, well, I know it's because of I have some kind of missing configuration parameters as my usual suspect. So in order for the control traffic to be initiated from the WAN edge routers, I have to ask myself, is a VBON configured? I need an IP address or a domain name. Is my DNS, server or static host IP configured properly if I'm using a host name for my VBON? And do I have a tunnel interface, configured, underneath that physical interface? Without that, I'm not going to be initiating any control traffic. Some other things, do we have a valid certificate, a valid root certificate? Is an organization name configured? Is a site ID, is a system IP configured? Without that, we're not going to be initiating any control connections. Okay, so one good command we could use to check this is show SD-WAN local properties. So this will give us a good view of what some of those things I just mentioned. It'll tell us if they're configured, if the certificate's valid, and we can also just check the running config to validate whether we have DNS set up and if we have our tunnel defined. Okay, so our next question is, for reachability is, if we've got traffic that's being initiated, is traffic even reaching the controller? So if I look at the show SD-WAN control connections history, I can see that I'm basically have a local error here, and it's essentially DTLS connection failure. So all that tells me is my connection is not establishing. So if I go to the VBON and I do like a show orchestrator connections history, I actually see information in that output. So at least I know traffic's making it to the VBON, right? Now, if I run this on run this for a different device and I do a show orchestrator connections history, I don't see anything. So does this mean that traffic's not making it to the VBON? Unfortunately, I don't know, because we actually need bidirectional traffic in order to see output here. So I still don't know. I could have traffic making it to the VBON and not making it back to the WAN edge. I'm not sure. I have to basically dig a little deeper and use some other tools in order to figure out what's going on there with the reachability. Okay, so on the WAN edge router, some of our usual suspects, we just talked about. Is a DNS server or IP static host, is it defined correctly? Is the default route to the transport defined correctly? And is the default route next top, the DNS server and the VBON, is it reachable? Okay. The other thing we need to talk about too is, if there's firewalls, or if they're present, do the firewall rules that we have in place allow for that communication to happen? Obviously this is, I have I'm not going to show that right here, but I did include a hidden slide that would basically explain, what ports need to be open for that communication to happen to VBON, but also a usual suspect. And next, what about TLOC subnets and IP addresses for those TLOCs? Are they advertised properly into the underlay? Because that also is another usual suspect, right? So if I have a dual edge router site that has two routers in it and I'm doing TLOC extension, it's very common to bring those up for the first time and to basically be missing control connections. We need to make sure that those TLOCs get advertised into the underlay properly. So when you have these TLOCs that sit on these TLOC extension links, The MPLS side doesn't have access to that route. The routes are missing. So we either need to make sure the service provider has a static route to our TLOC, or that we implement a routing protocol in order to advertise that TLOC into the underlay. And with the internet side, making sure that we have NAT configured on our physical interface so that that TLOC can be reachable from the underlay, and the internet can reach it from go to the post NAT address for that. So again, another usual suspect. For troubleshooting reachability problems, there's a number of tools we can use. A lot of them are just pretty straightforward, the ones you already know. The show IP route, show ARP, ping, extended ping, trace route, extended trace route. There is an embedded packet capture you can run on WAN Edge router, and that can help you figure out whether there's traffic coming into the WAN Edge router. And I included in the hidden slides also an example of how you could do that fairly quickly. We also have tools that you can use on the VBON side as well. Similar things, ping. There's an nping, which will allow you to change the UDP port number. So if I suspect that there may be like a firewall blocking me, I can actually test for that. The other thing you can do is TCP dump is also available to be used on the VBON. That will actually help you decide whether, am I even making, is this traffic even making it to the VBON? So that's very helpful as well. Okay. So we talked about reachability, right? The next steps are, let's talk about a little bit about authentication and authorization. Now, with authentication, when I have the VBON will actually validate the trust for the certificate coming from the WAN Edge router. That's all part of the authentication process. And in turn, I have the WAN Edge router that will do the same to the VBON. It will validate the trust of that certificate. The other thing that the WAN Edge router does is it will take a look at that certificate, pull out the organization name, and compare it to the one it has configured. So if it matches, that authentication will pass, and if it doesn't, authentication will fail. So sometimes you'll see this next step where the VBON will actually take the serial number from the device and check it against the list that it received from vManage to see whether this device is authorized to go on the network. I like to think of that more as the authorization piece. It helps me with thinking about the troubleshooting a little bit more. And so, where are the usual suspects in relationship to authentication and authorization, right? So we can talk about, there's times I've had, the clock time be off on, one of my WAN Edge devices. That it falls outside the validity of the certificate. And when that happens, you'll get these commands. You can run the show orchestrator connections history command and see a fail to verify peer certificate error. So basically the validation fails, right? Also, you could have situations where your root certificate is missing altogether. You also get a similar error, a fail to verify peer certificate. Now, with Cisco PKI, we used to have this problem show up a lot more frequently in older code versions because we weren't bundling the root certificate into the software until a little bit later. So you actually may not run into this problem very often unless you had like some enterprise root certificate and just forgot to load it on the router. But if you're missing it, you can actually pull the root path from the controller, or you can basically add your root certificate on the WAN Edge router again. In the case of a certificate org name mismatch, my WAN Edge is coming into the network, another usual suspect, and my org name does not match what my certificate and my VBON says, I'll also not pass this authentication. So interesting enough, there is an error called organization mismatch, name mismatch, but for the WAN Edge routers running iOS XE SD-WAN code, it tends to come up as peer board ID certified, not the certificate not verified. So, just keep that in mind when you're doing your troubleshooting. Authorization of the SD-WAN WAN edge routers. So in order for me to authorize a WAN edge to come into the network, it's got to be on my authorization list that I got from vManage. So this list can come from, the plug-and-play server. You can actually sync your vManage with the plug-and-play server to get your list. And then we can also do .csv files and upload those as well. Now, when we upload our WAN edge list, we have a little checkbox here that says, validate the uploaded vEdge list and send to controllers. So if we forget to click that box, once we upload our authorization list, all those devices that get put in there will be in an invalid state, meaning, we basically made their certificates invalid. So while they appear on the list, we're not giving them authorization to come on the network. So this is often a case that we see. We forget to check that box, and then we don't wonder why our devices can't come up. So I always make sure to check it. That way I can, ensure that those devices are valid. Else we have to go back and turn that on one at a time. So when I have a problem like this, which is, either my certificate's marked invalid or my device is not showing up in my authorization list, we tend to see an error, the peer board ID cert not verified error for this. So whenever you see this error, first thing I think of is, let me check my authorization list, make sure my device is showing up there. So I could do a show orchestrator valid vEdges on my vBond and see if my serial numbers show up. Okay. So now we're going to talk a little bit about vManage and vSmart control connections because let's say we've passed our authentication and authorization for our vBond, we're connected there. Our next stage is to essentially reach out to our vSmart, reach out to our vManage, and get authenticated and authorized and make control connections to those two devices. Now, the cool thing about this is if I passed authentication authorization with vBond, there's a huge chance I will also pass with the vSmart and vManage as well. So we really just probably need to focus on just reachability here. So a couple things I wanted to chat about in regards to this reachability is the concept of private and public IPs, okay? So each TLOC that we send to vSmart has a public and private IP associated with it. And so what does that mean? Well, private IPs are those IPs that are directly, attached to the interface itself. This is the pre-NAT address. Then we have the public IP address. And that is really the post-NAT address. And to realize that if we have a NAT device in the way, we really need to figure out what that post-NAT address is, right? Or else how can other WAN edge routers connect to us? So this is the job of the vBond, is to figure out, what our post-NAT address is and sends us that information, right? So now we've got a TLOC, we've got a private IP associated with it, we've got a public IP associated with it, and now we have devices that can connect to us even if we're sitting behind a NAT device. Okay? So in absence of NAT, like the private IP and the public IP are the same. But how do we know, whether a device should use the private or public IP to connect? Well, this is where colors come into play, okay? So colors identify a transport as either private or public, okay? So if we've got an MPLS network, that will give it that label or that color called MPLS, or anything else that's private. We've got a list of private colors, labels that we can use. And then on our internet side, we might give it, the label biz internet or, pub internet, and that's inherently public, public transports or public colors. And so depending on whether you have private colors and public colors will dictate whether you use a private IP address for connecting or whether you use a public IP address for connecting to those other SD-WAN devices. So Again, private colors, we're gonna be using them on transports where there's no NAT addressing. For our public colors, we're gonna be using those in public networks, or where you use public addressing that's either native or behind or a NAT device. The thing to remember is if I'm a private color and I'm trying to reach another SD-WAN device of a private color, I'm gonna use our private addressing space to discuss. Whatever attached to his private IP, I'm gonna talk to that IP address. If I'm a public color and I'm trying to talk to either a private color or public color, I'm gonna be using that other device's public IP to reach him, okay? So the only exception here is if we've got two public colors and there's a site ID that's the same, then we're gonna use our private IP addresses to talk to each other. Okay. So, reachability. Let me step back once, though. Why do we care about this? I guess is the question, right? Well, a lot of times, I don't typically see a lot of issues when we're running cloud-based controllers. But, if you're setting up for a POC, you're in a lab, you are maybe doing an on-prem controller-based, deployment. This is where I've kind of see where some issues pop up when it relates to color and what IP address are we trying to reach. So if you think about it, remember what we said, the vBond will determine what that public IP address is, right? If you have a bunch of controllers that are behind a firewall, you got your vSmart, vBond, vManage controllers are all behind a firewall. And you've got your vBond who learned, from your vManage and vSmart, that there's no NAT between the vBond and vSmart and vManage. So the vBond thinks, the vManage and vSmart are sitting, their private IPs, their public IPs, they're the same. Like say they're part of a 10 network. But the WAN edges need to actually reach these controllers through a NAT device. And they really need to know what the public IP space is in order to reach it. But the vBond thinks that there is no NAT in the way between the vBond and the vSmart, or the vBond and the vManage. So when it talks to the WAN edge router and gives them a list of how to connect to these devices, he's gonna tell them, oh yeah, connect to the public IP space, which is it was in the 10 network, right? So the WAN edge, of course, can't reach these devices through that IP space. So it's important to think about when you're building your network, the vBond's perspective has to match what the WAN edge perspective is. So if the WAN edge has to hand out a public IP that's post-NAT to the WAN edge routers, then it needs to talk to vManage and vSmart with their post-NAT addresses and not their private addresses. So anyway, this is where this comes up, and again, doesn't really come up in the case of cloud-based controllers, but it does, for other, if you're configuring this in a lab, if you're configuring some on-prem controller deployment, then it can come up. So just kind of keep those things in mind. So reachability are usual suspects. Is the WAN edge router trying to reach the vManage or the vSmart controllers using the correct IP address? And then again, firewalls come up yet again. If the firewalls are present in the path, do the firewall rules allow for that traffic to be able to happen? So I also included another hidden slide for firewalls because it was you guys might want to study that. There's a lot of information in there. Okay. So we are connected to vManage now, right? So my vManage status, I can take a look at it, and I can see under control status, it gives me an indication of what my connections, my control connections look like to my vSmarts. Okay, so I can either have all my control connections at the vSmart, I can have some partial connections, or I might not have anything. So I don't see anything. It could be I don't have vSmart connections. It could mean I just don't have a connection to vManage any longer. Okay. So we connected to our vBond. We now have connected to vSmart and vManage. And so now our last step in here is our WAN edge data plane connections. So our last step, we have our WAN edge device. We want to basically reach out and establish BFD sessions to other, WAN edge devices. And so we don't have authentication authorization here, right? We've already done all that. We've built our control connections, it's all said and done. So really our only, area where our usual suspects hide here are in reachability. So to kind of go back and review how these data plane connections happen, we have our WAN edge router. We've made control connections to our vSmart. We've created our OMP sessions, right? We take our local routes and our TLOC routes and those encryption keys, and we advertise them to the vSmarts via OMP updates, okay? So this vSmart will advertise those TLOC routes and those encryption keys to the V-edge, or for the WAN edges, and OMP updates to other WAN edge routers. And once we also, in turn, get that information to us in OMP updates, we can now create our data plane connections, our BFD sessions to our other WAN edge routers. Now, I didn't mention this before, but when we build those connections, essentially every TLOC by default will try to connect to every other TLOC, regardless of color. So if that's important, because you may have two transports that aren't supposed to communicate to each other. And if you have that, then you're not going to be able to form those data plane connections between those devices, right? So if you do not want, those transports to talk to each other over a BFD session, we can use the restrict keyword in order to basically prevent that from happening. Okay. Other thing we have to be concerned about when we talk about these data plane connections is we have a lot of NAT considerations. There's different NAT types you can use in your different sites. There's full cone NAT, which is your one-to-one NAT, your one-to-one static NAT, that's what that is. You've got also variations of NAT, like restricted cone NAT, as well as port restricted cone NAT. So the one-to-one NAT will essentially allow it'll basically map an inside address to one outside address, and any device can actually come into that router to that post NAT address and be translated, and a connection can be built. For these other NAT types, this requires us to actually initiate a connection inbound or outbound first to that one device that sits outside, and then we can have communication that goes on. With symmetric NAT, it's a little even more restrictive, because for every destination that I go to, my source port changes. So there's some, when you're trying to make BFD connections, there are some interesting things that can happen, and it can prevent us from actually forming these BFD connections. So let me just give you a quick example. I've got this NAT traversal example with a WAN edge router on the left, a WAN edge router on the right. The one on the left is running a full cone or one-to-one NAT. The one on the right is running symmetric NAT. So these devices make a control connection to vBond. vBond discovers the post NAT address, right? And it communicates that address back to the WAN edge routers. So now those WAN edge routers can make their connection to vSmart and tell vSmart, hey, by the way, here's my post NAT address. Devices can basically connect to me. The problem with this is that the symmetric NAT device, because of the NAT, will only allow the vBond to communicate back to him. He won't allow anybody else to come in. So when that full cone NAT device on the left side tries to initiate a connection, the connection's blocked. But the device on the right can connect to the full cone device and build that connection there. And then the left side WAN edge running full cone can then reply back to this WAN edge device. And now the filter is there, right? Because it initiated that conversation to that left-hand WAN edge router. And so now a connection is built. So let me just show you this slide. There's a lot of cases where certain NAT types are incompatible with each other, right? where we're not going to be able to build these BFD sessions. So we always recommend at the hub site that you implement like a full cone or one-to-one NAT solution. And at your branches, if you run symmetric NAT and you can't connect to another branch, you can at least always go through the hub. But to keep in mind that this will affect your BFD, the ability to build these BFD sessions. And I got a quick slides on firewall ports because we also have to keep in mind with the firewall ports in this section as well. You can take a look and see what the source and destination ports are. You can run like a show SD-WAN tunnel statistics table command and see the BFD sessions that are being built, what their source and destination IPs are, or sorry, their port numbers are, so that you can make sure that those are being allowed through. So if I summarize our usual suspects here, it's, does the NAT design, allow BFD sessions to form between those WAN edge routers? If the firewalls are present in the path, do we allow the firewall rules and do we allow that communication to succeed? Are all the control connections established? Because if you don't have a control connection established, you're not going to see a BFD session form. So it's always important to make sure that the control connections that you troubleshoot those first before you worry about data plane connections. And then there's another thing is there a policy in place that's going to actually filter out some of my TLOCs that's going to prevent that WAN edge to WAN edge BFD sessions from forming? Often, we might do a hub and spoke topology, where we would filter those TLOCs and make sure those branches can't talk to each other, but they can only talk through the hub. And if you go back to the vManage GUI, we can actually see the BFD sessions here. It's going to show up under site health, so you can kind of see if you've got full WAN connectivity with other WAN routers, or if you've got the partial connectivity, or maybe you don't have any connectivity, which also could mean you don't have connection to vManage. Another cool table to use is this device bring up. We can go to configuration devices, and we can actually see what stage is our router in as we bring it up onto the network. So, did we pass VBON authorization? Did we receive a configuration from vManage? Did we establish our control plane connection? Did we establish our data plane connection? So this is kind of a cool tool to use to see what stage we're at. That's my conclusion. So let's talk a little bit about, let me just summarize what we talked about. We talked about, in the onboarding process, we've got several stages, and we've got devices that hide in different areas, right? We have them hiding in reachability, authentication, and authorization, right? So when we talk about reachability, there's lots of examples of that. There's, we might have missing parameters that would prevent us from initiating traffic. We may have connectivity problems from DNS configurations, default route configurations, or firewall ports blocking us. There may be TLOC extension subnets not being advertised. We might have incompatible NAT types, or maybe we have configured policy that's preventing us. And then, of course, authentication. We covered, we have an organization name mismatch. Do we have a missing root certificate, or maybe our clock time is off? And then on authorization, our certificates, do we have a certificate marked invalid, or is this device missing from our authorization list? So I'm hoping that you guys can take away something from today. Like, I'm hoping that some of the things that we discussed can help you when you go and you deploy your SD-WAN network, at least figure out maybe a strategy for being able to find these problems fairly quickly. Just a reminder to, if you guys can fill out your surveys, that would be greatly appreciated. Apparently they're giving out Cisco Live branded socks, if that's what you're interested in. And if you guys are interested in learning and certifications, there's also some of that in the World of Solutions. You can kind of drop by. Also, if you want to continue your education, you can go see the showcase for various demos. You can basically do some walk-in labs, and of course, you'll have the on-demand library that will be online, after this event. Also, if you're interested in any SD-WAN demos, I have a list of them in here, which is in the World of Solutions. So feel free to go and check that out. And I've got like about 5 minutes left. If if you guys want to ask some questions, or if you guys want to come up and ask questions, or we can go outside and finish answering questions. Yes.
You ever see service provider issues with the DTLS connections towards VLAN or vSmart? Anything strike you there? Like any kind of common things that might happen with certain internet or private WAN connections? It's always been an issue in the past, especially with IPsec, that some providers kind of mess with your legs.
Let's see. I would say, okay, so the question is, have we seen any issues with connections from the service provider, like anything going on with the service provider with regard to control connections, right? DTLS connection. I'm trying to think outside of basic reachability kind of issues. Not necessarily in control of the service provider, but if you've got MPLS and you're trying to do control connections over that, usually that, and you're doing cloud-based controllers, for example, you need some way to actually get to those internet-based controllers. And so there's different choices that you can make there. So if your service provider has an extranet, you can reach the internet through there. Most people actually go through the data center, where they would have access to both transports. So sometimes there is some reachability problems, and it goes back to routing. But yeah, we've seen those kind of issues too. But that piece is like, basically, how's your routing? What does your routing design look? How do you, are you following, are devices following a default route, through the MPLS to get out to your internet? Is that all set up properly? I think that's kind of what I've seen. Anybody else have questions? Oh, yes. I'm sorry, say that one more time.
Do you recommend putting a firewall in front of the SD-WAN place?
Normally, you certainly don't have to. Like for branches, there's really no need to, but you tend to see firewalls placed in data centers, right? So that's where I tend to see them most of all, is right there. And so I just kind of mentioned the firewalls as a thing, because they tend to be at those main locations, at those data center locations. I don't see them very often, or maybe in big campus locations too, but I don't see them very often in branch sites because you really don't need to have them there. Yeah. Was that your impression as well? Yeah. Okay. Yes?
Sorry.
No.
Best practice recommendation for where you drop the edge devices in your data centers, like your actual HQ locations. Because SD-WAN docs online kind of show that it sits behind everything, and it builds its transport layer over existing paths. But I've also seen people recommend putting it at the edge and parallel. There's a couple different options. What is Cisco's recommended?
Okay, well, I wrote the design guide. So we tend to see often is that, your data center tends not to be greenfield, right? So you tend to, what we recommended would be to kind of sort of put them in behind the existing, right? Connect to your existing CEs. Because, yeah, and the reason for that, for many reasons. For one, it makes that connection, like if you're trying to do MPLS connections to the internet, like to get to your cloud-based controllers, it makes that path very easy instead of having to try and go through your WAN edge devices. The migration to SD-WAN, depending on how big you are, may take some time, and you might need those CEs in place to talk to non-SD-WAN sites for quite some time. And that's another reason why you might do that.
What would the end state be? The edges being at the front of everything?
Not necessarily. And perhaps your small branches, yes, you might want to. I would, you may not want that for your data center routers. It's obviously a choice.
Because Meraki treats their SD-WAN deployment as like VPN concentrators.
Okay. Yeah. So, it's sort of a choice. I kind of find it more advantageous to keep it behind some CE routers, and you have a lot more control over your routing. And And then also, like if you need services from your service provider, you also have direct access into the MPLS and not have to go through the WAN edge routers to do that. So there could be lots of reasons for that, okay? It looks like we're out of time. I can say a couple more minutes. You guys can come up and talk to me, however you guys want to do it.